Chapter 5, Network in Graph Theory. First of all, we have to know what is network and what is a graph. Okay, so let's look at the highlight word here. A graph is interpreted as a series of dots which are either linked or not linked to one another by lines. So this is an example of graph. We have dots, 3 dots here. And then we have blue lines connecting dots. Each dot is known as a vertex, and the line joining 2 vertices is known as an edge. So every dot here are known as vertex. The symbol of vertex is capital letter V. Okay, so let's say this is the first vertex, V1. This is the second vertex, V2. This is the third vertex, V3. Okay, so we have 3 vertices here. Vertices is plural and vertex is singular. The line joining 2 vertices is known as an edge. Okay, so the blue lines here, okay, example, this blue line joining vertex 1 and vertex 2. Okay, so this is known as an edge. The symbol of edge is capital letter E. Okay, so this blue line joining V1 and V2, this is the first edge, so we can write it as E1. And this is another line joining V2 to V3 or V3 to V2. This is another edge, E2. And this is another edge joining V1 and V3, E3. Okay, when we write V1, V2, V3, E1, E2, E3, we have to write it in small letter. Okay, so this is an example of graph. We have vertex, which means dots here, and we have edge, that means the line joining the dots. Okay, so you have to remember these 2 very important terms, vertex and edge. Vertex is the dot, edge is the line joining the dots. A network is part of a graph with the vertices and edges having their own characteristic. Okay, for example, we will have land transport network. Okay, for land transport network, the vertex can be regions, towns, cities, or certain buildings that are linked. The edge can be roads, highways, or railway lines. For example, okay, land transport network. Okay, let's say Miri is here, Brunei is here, then Bintulu is here, and we have Cebu here. Okay, so every dot here is known as vertices. So this is one vertex, V1, V2, V3, V4, which is regions. Okay, and then for edge. Okay, for example, when we travel we can travel from Cebu to Brunei through roads. Okay, so this is one edge, H1. Okay, we also can travel from Bintulu to Miri through roads. Another road here, E2. Okay, from Miri to Bintulu, we have 2 roads, 2-way. Okay, this is another road here. So this is another edge, E3. From Miri to Brunei, okay, we have 1 road, so E4. So we have 4 edges here. Okay, so this is an example of land transport network. Another example will be social network. The vertex is individuals, groups, or organization. The edge will be types of relationship such as friends, colleagues, or families. Okay, for instance, this is pupils A, B, C, D, E, F. So I have 4 pupils here, and these 4 dots also represented as vertex. Okay, so this is V1, V2, V3, V4, V5, and V6. So let's say D and A, they are couple. A and C are siblings. C and F, they are cousins. F and E, they are colleagues. B and A, they are friends. B and E, they are schoolmates, for example. Okay, so the blue lines here is represented by types of relationship between each of them. So this blue line is also known as edge. Okay, this is H1, E1, E2, E3, E4, E5, and so on. Okay, this is an example of social network. Let's look at some important terms for this chapter. Okay, first one is graph. So the symbol of graph is just capital letter G. Okay, graph is denoted by a set of order pairs, which is V, E. Capital letter V is vertices or vertex, E is edge. Okay, you have to remember these two, vertices and edge. Okay, V is a set of dots of vertices V1, V2, V3 until Vn. E is a set of edges. Okay, E1, E2, E3, En. Okay, and then we have degree. Degree is a number of edges that connect two vertices. Okay, the sum of degrees of a graph is twice the number of edges 2e. Okay, and also remember, degree are always even number. Okay, this is very important. Okay, this is just the theory of graph, vertex, and edge and degree. So let's apply to the questions here. So what do you understand about simple graph? A simple graph has no loops and no multiple edges. The sum of the degrees of the graph is twice the number of edges. So this is known as a simple graph. No loops, no multiple edges. Okay, example. Based on the simple graph given, determine V is vertex. And this means number of elements in the vertex. Okay, so let's look at this graph. So vertex is a dot. So we have 1, 2, 3, 4, 5, 6. 6 dots here. And this dot is named as 1. This is 2, 3, 4, 5, 6. So for vertex, we have to write it in set. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then cross bracket. Okay, remember for set, we have to put this curly bracket. Okay, this curly bracket is very, very important. And then number of elements in vertex. So 1, 2, 3, 4, 5, 6. Altogether, you have 6 numbers here. So 6. B, edge, and number of edge. Okay, edge. Edge is the blue line. Okay, so let's start from this one. So from 1, it has 2 lines going out. 1, 2. So you have 1, 2 here. Okay, we have to put it in bracket now. 1, 2. So 1, 2. And then 1, 5. Another line, 1, 5. So 1, 5. Okay, no more line going out from 1. So only 2, 1, 2, and 1, 5. Okay, now we focus on 2, vertex 2 here. So there are 3 lines going out from vertex 2. First line will be 2, 1. But 2, 1 is similar as 1, 2. So we do not need to repeat it again because we have 1, 2 already. No need to write 2, 1 again. And then another line will be 2, 3. 2 to 3. So you have 2 to 3 here. And then 2 to 4, 2, 4. Okay, after that we focus on 3. So there are 2 lines going out from 3. First one will be 3, 2. But 3, 2 is similar with 2, 3. Okay, so we do not need to repeat it. Another line will be 3, 4. Okay, so we write it down 3, 4. And then for vertex number 4, there are 3 lines going out from dot 4, which is 4, 2. 4, 2 is similar as 2, 4. So no need to repeat. 3, 4, 4, 3, no need to repeat also. 4, 5. Okay, so we write it down. 4, 5. Okay, for dot 5, there are 3 lines going out from 5, which are 1, 5. 1, 5 already have. 5, 4 or 4, 5 already have. So the last one will be 5, 6. So 5, 6. Okay, so number of elements in this set E. We have 1, 2, 3, 4, 5, 6, 7. We have 7 pairs of edge here. Okay, first one, second, 3, 4, 5, 6, 7. So number of elements in set E is 7. Okay, there's important here. The edge for the vertex pair 1, 2 is also the edge for the vertex pair 2, 1. 1, 2 is equals to 2, 1. So you do not need to repeat them. Okay, for C, sum of degrees. Okay, still remember you are given the formula for sum of degrees. Okay, this is sum of degree equals to 2e. 2 multiplied with e. Okay, 2 multiplied with e. So number of elements in E, we have 7 pairs here. So 7. 2 times 7, 14. Or if you do not know this, okay, if you forget this formula, you can count it by yourself. Okay, so how to count? Okay, so we start from dot 1. From dot 1, there are 2 lines going out. Okay, so dot 1, degree for dot 1 is 2. Okay, that means there are 2 lines going out from 1. From 2, there are 3 lines going out from 2. So 3 here. Okay, dot 3, we have 2 lines going out from 3. So 2 lines, 2. 4, you have 3 lines going out from dot 4. 1, 2, 3. So 3 here. Dot 5, we have 3 lines going out from dot 5. So 3. Dot 6 only have 1 line. So 1. Total 2 plus 3 plus 2 plus 3 plus 3 plus 1. So you have 14. Okay, example 2. State the number of vertices, edges, and the sum of degrees for the following simple graph. Okay, so let's look at A. Number of vertices. Okay, number of vertices means how many vertex or how many dots. For number of vertices, how many dots? So 1, 2, 3, 4, 5, 6, 7. 7 dots. So number of vertices is 7. Okay, number of edges. How many number of edges here? So, we start from vertex 1. So only 1 line going out from 1. So 1, 7. This is H1. Okay, from 2, there are 2 lines. Okay, this is H2, H3. Okay, 3 to 6. Okay, this is H4. 3 to 4, this is H5. 4 to 5, H6. 5 to 3, this is H7. Okay, so there are altogether 7 edges. Okay, remember you do not need to repeat. Okay, for example, 6 to 3, 3 to 6, they are the same. Okay, so this can be only 1 edge, E4. Okay, and then for sum of degrees. Sum of degrees. Okay, you can use the formula 2 multiply with E. 2 multiply with E, E7. So they are altogether 14. Or if you do not know this formula, you can count it by yourself. How? Okay, so you have to count it one by one. Okay, write like this. Degree 1. Okay, there are 7 vertex here, so we have to write until 7. Degree 2, degree 3, degree 4, degree 5, degree 6, and degree 7. Okay, so let's count one by one. So vertex 1, only 1 line going out, which is 1, 7. Okay, so for dot 1, only 1 degree. Dot 2, 2 lines going out from 2, so 2. Dot 3, 1, 2, 3, 3 lines. Dot 4, 1, 2, 2 lines. Dot 5, 1, 2, 2 lines. Dot 6, 1, 2, 2 lines also. Dot 7, 1, 2, 2 lines. Okay, so 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. And 12 plus 2 is 14. So altogether 14. Okay, you can count it one by one or you can use the formula. Okay, for B, state the number of vertices. Okay, start from number of vertices. Number of vertices. So how many dots here? A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6, 7. Okay, also 7. Number of edges. Okay, you can name the edge. Okay, for example, A, B is E1. This is E2, E3, E4, E5, E6, E7, E8, okay, E9. Okay, so number of edges here will be 9. Okay, last one, sum of degrees. So sum of degrees. Okay, you can use the formula, which is 2 times E. E is 9, so altogether 80. Or if you do not want to use formula, you can count it yourself. Okay, but we have to count it one by one. Okay, so A to G, degree A, degree B, degree C, degree D, degree E, F, and G. Okay, so let's count from A. From A, there are 2 lines going out from A. So degree of A will be 2. From B, there are 2 lines going out from B. So 2. From C, there are 1, 2, 3, 3 lines. D, 1, 2, 3, 3 also. E, 1, 2. F, 1, 2, 3. And G, 1, 2, 3. Okay, after that you just add out all the numbers here. you will get 80. Try to do question number 1, A, B, C. Okay, for each graph, determine vertex and number of vertex, age and number of age, and the sum of degrees.